Okay. Let me zoom into this. So it's just measuring instantaneous velocity. So a ticker timer produces a series of dots on a tape which can be analyzed to determine the displacement between 2 points at the time taken between those 2 points. So you know that velocity is the change in distance divided by time, right? You're aware of that.
Yeah.
So we know that. Let me just get this. Yeah, we know that the displacement is measured in meters. The thing is, you're gonna have to measure with a ruler. So since I don't have it with me, you're gonna have to do it like physically because I'm just using a PC.
Yeah.
So the time can be measured in the form of period, which is.
Let me just get a ruler quickly.
Oh, okay, no problem. Let me just erase this.
Okay, I can't really find like a long ruler, but I have like my small one.
The
That's like
thing
this.
is, like, I'm busy looking through this, right?
Mm.
And then, like, they say to calculate the instantaneous velocity at a certain point z on a tape, you need to mark off one or more spaces before the point z. You know,
So yeah.
so you need that. So from this, you need to find that ruler. But to be honest, this is just like information. You know,
Mm. Mm.
this is
That
mostly
is.
information. So I don't know, like, let's say for now we just studied through this information,
And try to
uh,
find activities.
then maybe we'll just look through activities in an exam situation because like those are the more difficult ones. So is that fine?
Yeah, that's cool.
Okay.
I just want to have an idea. Like, I don't want to go and like go there with no knowledge of what to do.
Oh, like when it comes to velocity and acceleration.
Yeah.
To be honest, these are very simple concepts, man. As you go further and further, like velocity, you can just calculate it like right off your head.
Mm.
It's
But I
gonna.
think let me just ask. Let me ask my friend if this one to do like graphs, like the graphs of motion. You know, all
Yeah,
that. Let me just ask you.
but I'm pretty sure you're gonna find like graphs of motion in your paper one test. So let me just open this one and this one. This is the 2018 memo. So but can you see it? Can you maybe ask? I think this is the graph that you're talking about.
It said we did that velocity to time. Velocity to time.
Yeah, this is the velocity to time graph.
Mm,
Like question 1.2. Can you see? Like, can you see? Can we start with this one, or are you still busy?
okay. Yeah, I said there was graphs involved, but it just doesn't know which one. So it could either be uh, a graph of motion, a velocity versus time graph, or displacement versus time graph. Mhm. You can hear me? Hello? I think your mic is muted.
Oh, can you see my screen? Like, can we do question 1.2?
Yeah, I can see that.
Yeah, so yeah, I'm sorry, like it was muted. So they say a car is traveling at constant velocity along a straight road. It then slows down uniformly. Which of the following velocity versus time graphs represents the motion of the car? So, like, the first thing you need to know is that the car is traveling at constant velocity, right?
Mm-hmm.
At first, then it's gonna slow down.
It's C. It's C.
Exactly. So, like, graphs aren't that hard to interpret, as you can see. You know,
Okay, so basically, if this is a question, I know it would be easy because they're giving us the graphs and they're telling us like how the graphs is, and they're just telling us to like pick one. But now, would they ask me to like draw one? If they had asked me to draw one, I think I would like,
that's why you have an issue.
yeah. But then
Let,
again, like, but will they always give you the information and then tell you what to draw?
yeah. Most of the time they give you the information. Like they'll just tell you the scenario, right?
Mm.
After giving you the scenario, they tell you draw this versus this for that particular scenario.
Yeah, I see, I see.
So let's say let's like as I'm scrolling down, let's just come up with an example.
Mm.
Let's say you're driving up a hill, right?
Mm.
So at the bi- at the bottom of the hill, let's say, yeah, actually, let's say you're driving down a hill, right?
Yeah.
So at the top, and as you're driving, your car is accelerating, okay?
Mm.
So that means like when you go down, your car is accelerating. So the acceleration goes up as the car goes down, because let's just say it's in free fall. That means you're just pushing it down, you know. So it's just rolling down, right?
Yeah.
So as your car is accelerating, they say draw the velocity versus time graph for that particular scenario.
Mm-hmm.
Now, you know that acceleration is directly proportional to velocity, right? Can you hear me?
Yeah. Mm-hmm.
Yeah, so it's direct acceleration is directly proportional to the velocity. Let's just say the change in velocity, because as the change in velocity is greater, the acceleration is greater, right?
Yeah.
So because so we, if we're gonna look for a velocity versus time graph, let's just draw this real quick. Velocity, time. The velocity versus time graph for an accelerating car. Like, I'm just gonna give you like three graphs, right? Then you tell me which one is right. So it can either be like that, it can be like this, velocity versus time, or it can be like this. Like, just from the looks of this, which one do you think is correct? For uh, velocity versus
Mm-hmm.
time graph of an accelerating.
I would say the one on the top right.
Which one? Let's just say A,
Okay.
B, or C.
You're saying is B correct? It's
B.
either B or A. Mm.
Ah, man, nice. Because the car is accelerating, right?
Mm.
So you
So A.
know, sorry.
A.
Yeah, like the correct one is A. B is for a decelerating car, you know. So for
Okay.
B, it's when the car is slowing down.
I was gonna say A because I can see it's going up, but like
Yeah,
the B is also like I don't know.
it's going
It
down
feels like
like,
it's going down.
yeah. So for B, it's when like the car is coming from a high velocity to and
Okay.
decelerating to zero, you know.
Mm.
Then this is the max up there. This is the maximum velocity. Then this is zero velocity, 0 meters per second. You see?
Okay. I see.
Then for A, the max is up here. You know, it keeps going up because the car is accelerating. So the velocity is gonna change constantly with time.
Mm.
So do you understand that part?
Yeah.
Okay, so
Uh, But I think I'm more worried about calculations and stuff.
about what?
Calculate like measuring. Like
Oh,
like
the
you
thing
see
is,
on. Mm.
the thing is, when they give you a graph like this, right? A velocity versus time graph, you're gonna
Yeah,
know
from the
that
graph.
the gradient of the graph, right? the gradient of the graph, it's gonna be y2 minus y1, right? That means it's v2 minus v1 divided by t2 minus t1, right?
Yeah.
Then that is the acceleration, because acceleration is equal to delta v divided by delta t.
Delta T.
So this delta, it just means the change in velocity divided by the change in time.
Yeah.
So this delta is basically a sign that it's something final minus initial. So I think you guys, they're mostly gonna give you a velocity versus time graph
Mm.
or a displacement versus time graph. Where for the displacement versus time graph, you know that the gradient for displacement versus time graph, right?
Mm.
The gradient for displacement versus time graph is gonna be d2 minus d1 divided by t2 minus t1, which is gonna give you the velocity. Is that fine?
Yeah.
Okay. So let me just erase everything. But with this, like, do you have any more questions?
No, not in this. But I still wanna. If you go back to the page I sent,
Which one?
see the papers that I sent.
Oh, okay. This one.
Yeah. Like, can't you find like an example that I can do?
For velocity and acceleration.
Mm.
That's what I'm trying to do, like find an example in this question paper. I think, yeah, I think this is right because they're asking for average speed and all those things. So yeah, question 2 is a question based on velocity and acceleration.
But can we do one together and then like once I understand it, then I do one myself?
Okay, so
Is there another question like this in the question paper? Like what
um
other?
like independent dependent variable, change of position per unit time. Yeah, this is also related to like velocity and all that stuff. That's why, like, even here 3.5 they say draw the velocity versus time graph for the motion.
Mm.
Yeah, so let's just do question 2. I'm gonna do question 2 with you. Then have i
Yeah, and the question.
have I sent you this question paper, or maybe I should just send it to you, then you'll do question 3 on your own time, right?
Yeah, I can try that. What are the questions I asked you?
Okay, and let's start. A brother and a sister walk walk home from school. They walk 500 meters to the east. The brother realizes that he has left his book at school. He returns to school. His sister continues walking another 800 meters to their house. She arrives home in 30 minutes after leaving school, right?
Yeah.
So they say calculate the average speed of the girl from school to her home. So the average speed, that's basically the average velocity.
Mm.
So that's gonna be the change in distance divided by the change in time, right?
Yeah.
So the first thing you need to know, you need to like label everything out. So we know that our change in distance is gonna be 500 meters plus 800 meters, right?
Mm.
So let's just say it like this, right? From school, that's 0 meters. That's our initial position, right?
Yeah.
Then when you get home, that's our final position. That's our final position, right?
Yeah.
And then from school to home, that's 500 meters plus 800 meters, right?
Which is the final.
Yeah, so it's gonna be 500 plus 800. I think it's gonna give us 1,300 meters,
Yeah.
right? So our displacement, right, which is the change in distance, that's gonna be x final. Okay, this is our
Mm.
final destination.
Destination.
Then this is our initial. Um,
Mm.
so that's gonna be 1,300
Minus 0.
minus 0, right?
Yeah.
Then our delta, our change in time. The first thing we must do is convert this 30 minutes to seconds, right?
Yeah.
So that's gonna be 30 minutes. That's gonna give us 30 multiplied by 60. That's gonna
800.
sorry.
1,800.
So 1,800 seconds, right?
Mm-hmm.
So that's gonna be 1,800 also minus 0, right?
Yeah.
So that means our velocity is gonna be 1,300 divided by 1,800. So what's the answer for that? 13 over 18.
Yeah.
Um, can you convert that into decimals? 13 over.
So it's 0,722.
Okay, 0,72 meters per second. So that's the average speed of the girl from school to home. Do you see it?
Yeah.
So like the most important part is that you have to show that you convert, because this is a 4 mark question. You just
Yeah.
you take this and substitute it above, take this, substitute it below, and then show that you add 500 and 800, show that you add these. That's another mark. And show that you convert the time into seconds, then that's another mark. Then this is 1 mark, and the equation itself is another mark.
Yeah.
So they say,
Send me the question paper. Eh?
sorry.
You're gonna send me the question paper.
Yeah, I'm gonna send you the question paper.
Okay, thanks.
So with this one, that's why like they need a diagram, you know.
Yeah.
So I don't think, let's just draw it, né?
Okay.
Even though it's not gonna be to scale and all that stuff. So I'm just gonna draw it. I'm just gonna draw this This is the school. This is home. Oh, that I have 10 minutes left. How about I restart the meeting now so we don't have to worry about it cutting later.
Okay.
Okay. Let me